Hey guys, Brian here. Welcome back to the shop. As things get perhaps more redneck here every day, I couldn't get this shaft out still. It's still got too much bend in it, and I don't want it wobbling around and putting a bunch of force in everything when it's still bent. So what I'm going to try and do is to heat it and spin it at the same time. And hopefully by doing that, it'll straighten itself back out a little better, and then maybe I can get it out and try and straighten it better, or maybe it'll be good enough to, if it's not walking around, I really don't need to straighten it anymore, but it'll be good enough, So, let me show you what I got going on here. Bailey's keeping an eye on me. Okay, so we've got this beautiful Westinghouse Type SK DC variable speed motor here, and the way it's set up is, of course, you've got two big wires that are for the armature rotor part inside, and you've got a field wire for the outside. And what this is intended to do is to have it's got two little wires for the field and the big wires for the main rotor inside. The main rotor is designed to get the full 230 volt power all the time, and then the field can get variable voltage through the resistor on here, and by varying that they can vary the speed of this motor from like 400 RPMs to 1600 RPMs. So it's got and it still has full torque capability across that entire range because of the full power going to the rotor inside. So it's pretty good design as far as that goes. But what I've done is hooked the field to the main windings, because that eliminates a lot of wiring here for me. And then I've got my Miller welder hooked onto it, onto the leads, so I can spin this thing with some DC power. Looking on the welder's 80 volts max on DC. It's a constant current welder, not a constant voltage welder. So it drops, as the amps go up, the volts drop down, but basically it kind of starts slow like this because of the volts being low at the high inrush current, and then it speeds on up. But it does work. I've tried it. Initially I had it hooked to the Hobart and was using that, but it's only like 30 volts max. So using the Miller, I'm getting some more output out of it and a little more speed than what I could get out of it with the constant voltage welder, with the MIG welder. So that's how I've got it hooked up, and I'm using the foot pedal for the MIG to turn it on and off over there when I want it. So I'll be able to control the spinning with the welder still on. So let me start the welder up here and I'll show you this thing cranking. Alright, so when I want it to spin, I just hit the go pedal. Rocking the box pretty good, so hopefully I'll be able to get that out of it. Fire up the rosebud and see what we get. Well, after thrashing on the lathe for the better part of a day, the drill, finally got the shaft out of it, but now I got a bit of a new problem. It's a little too long for my lathe. I need about a 10-foot lathe in order to get that bar in there. And it's too big to go through the headstock. One of the things that, the only thing that I don't like about the Monarch lathes is that they got a small spindle bore, so you can't stick much through them. So I got a 1 7/8" 6-spline shaft there, and it's too big to go up into the headstock, and it's too long to fit on the tail. I got it slid out as far as it'll go, so I'm not sure exactly what I want to do here next. It would be nice to straighten this in the lathe because I can see and indicate and travel down it and figure the bow spots pretty easy with it there, but it may not be practical because I don't know how much straightening I can really do in the lathe. Anyway, I can push on it pretty good with the compound there, but may just have to take this into work and try and straighten it there in the hydraulic press using a straight edge or something on the sides of it to try and get it straight. So I have to ponder on that and decide what I want to do. If I want to take the tailstock off, I could put the steady rest up in the middle of it and use that to hold the end of it, because there's really only a 3-foot section that I need to be straightening in. The rest of it's okay going out the end, what was beside the 7-foot arm. So I have to think about that. If anybody's got any ideas or suggestions, I'm open to what you got there, and see what I decide to do about trying to get this the rest of the way straight. I've got it pretty good because I couldn't have got it out through the collars otherwise, but it's really tight. I had to do a lot of beating and prying in order to get it to come through the holes, so I know it's still not as good as it could be. But it's a whole lot better than it was, but I'd still like to see it better than what it is now. If I had a set, I should have bought a set of right rollers a while back, and I could have had them made up, and maybe I could have used that for this. Although with the splines, I guess you'd have to put it on collars to roll it on there probably, or it would just bounce into the holes. But I guess you could always just read the tops. It wouldn't really matter a whole lot. You just read where your highs and lows were. So there's all kinds of various methods to go about that. So I'll just see what I can come up with. Thanks for watching. Thanks for subscribing. I'll catch y'all later. Well, I thought about it for a minute, and I think the obvious solution is I probably just need to buy a bigger lathe.